Hello, my name is Christian Schorr and I am going to tell you how to lay out using a Leica 3D DISTO. A layout on a straight line works perfectly using a rotational laser such as a Leica Roteo. However, what if the design is not just on lines but on any other shape? This design is curved and it represents the drilling positions.
The only straight line is the ground line, which gives the direction towards an existing geometry. The data can be stored as a flat list in a CSV file or taken straight from a DXF file created in AutoCAD or any other drawing software. I start doing the layout by choosing the projector application. The software asks for the measurement of the working area. The purpose is to measure the working area that defines the surface of the layout. The surface might be the ceiling, the wall, or the floor, and thus it needs to be defined first. I start doing the measurement in the corner of the room. First point is measured. Now let's continue doing the shape of the room. We are actually missing now one corner of the room. That doesn't matter because that corner is not a place where the layout takes place. By the way, you are now going to see me doing this video. See, the last point 5 and the first point number 1 are going to be connected if I choose to close the polygon. I could now measure further points of interest. And I see the result of the measurement of the floor of this room. I have missed this corner, as I said, and you see the slope of this area is close to 0, which is supposed to be, because it's supposed to be a floor of a flat building. I now decide to secure the existing location, choosing the location feature. The location feature asks me to measure a couple of target marks, where I can either pick the target marks that are part of the delivery scope or any other natural target. Doing this, it allows me to come back later, anytime, choosing the relocation program to set up newly on the same position or on any other position that is appropriate to continue doing the layout. I would like to continue doing the second secure point. For securing the location and relocation, it is always recommended to target as precise as possible. And I'm doing a point number 4. For this I'm choosing a natural target, not one of the target marks. So, choosing the middle of this power plug works in the same way. No, 4 is enough. You see the location of the secure points in the picture. And I go and save the measurements. In a new folder that I call Design. And the file name, I choose the default one that's proposed by the system. Now we are ready to insert the design in the reality. So first, we import the file into the projector. We could type in a grid or import a DXF or a CSV file. We have prepared our designers in a CSV file. Now we insert it here. Now of course we have to move now the grid design or any other design to the final position, because the system does not know automatically where it belongs to. I have various ways of manipulating the design versus the measured points and lines. First, I can start turning the design in the desired way by doing a 90-degree turn. I have to do this 3 times, so actually it's a 270-degree turn. Okay, now the design is turned in the way I want it. So actually I want the design, the handrail, to go this way, like this. So we have to shift it. So for example, I can pick this line and see there's a distance of 5 meters plus 2 centimeters of this point to this line. I can go and edit and change this to, for example, 10 centimeter. Now it's pretty close. And I also see the alignment point out of the design here. Well, that one is important because remember, we want the design to follow a certain geometry, and in this case the geometry is defined by this wall, right? So I click on the blue point and I can draw a line to the initial point of the rail to establish this blue line within my design. Now I can pick any wall, for example this one, any wall like this, and make the design parallel. Of course I don't want it parallel to this wall, I want it parallel to this wall. I only did this intermediate step to show you how it turns. Okay, now those lines are perfectly parallel. Only remaining thing I have to do is to change the values, the distance to the point 1. So the designer wants me that this point starts with a 1 meter distance to this wall. So you see the grade value of 5.8. I simply can change this to 1 meter. Alright, and I also want that the design is 2 meters away from this wall. Since we are a bit on a bad scale here, I can zoom in that you see better what I'm doing. Okay, here we go. So now we are 8 centimeters away from this wall. Again, I click on the gray value and I change it to 2 meters. Right? And now we do the cross check. Is the point still 1 meter away from this wall? Now this is not the case. Well, the reason is that this angle between those walls is not perfectly 90 degrees, and this is while the shift to the initial wall here, 2 meters, has taken it away a bit from the 1 meter I entered initially. So we just need to enter again 1 meter. And now we make the cross check. That was a small change, so this is still 2 meters. So back to original scale. See the alignment, 2 meters to this wall of the first point, 1 meter to this wall, and the whole structure is parallel to this wall too. Again, a short summary what we did so far. We have measured the boundary of the surface that defines the surface for the layout by taking a couple of points. Then we have loaded in the design from a CSV file, or the CSV file we had prepared in the office. Then we did the alignment by turning and shifting the CSV file versus the existing geometry, and now we can start doing the layout. This is assistant says select point and measure, and this is what we're doing now. So we select the first point of the design and press DIST. And this is where the system goes to. I see the red dot that indicates that this point is measured and laid out. I also see that it is 3 mm above the original surface definition. And if I check the viewfinder, I see that the system points on this initial layout point, right? Now I can go at the spot where the red laser shows and make the first mark. We've done the layout of the first design point on the floor, and we can choose the toolkit function to easily transfer the same point on the ceiling. We only need to measure where it already targets to get the initial point, and now we roughly measure where the plumb point is expected to be. So for this we're going to target up on the ceiling and let the system do the fine-tune search. And here we are. We've transferred the point to the ceiling, and we also got the distance between the floor and the ceiling point. We can close the toolkit and see where we're targeting. Right. The layout process easily continues by choosing subsequent points from the design, hit DIST, got the system turned to the target and measured, and layout, choosing a new mark.
You're seeing me proceeding, doing the layout on the floor, and I don't even need the control unit. I can choose the infrared control to skip from one layout point to another. You have to understand that I'm choosing target marks that are adhesive and no real nails. Otherwise, my boss would kill me for making some damage to the demo room floor. Now you see both the control unit and the red laser in this picture, and you could now go and lay out this point by drilling a hole or by making a mark where the red laser is. Well, now you can use the control unit while we're working in wireless mode like a laser receiver, and just take some sort of nail and fully rely on the crosshair on the middle of the set out point. I had to change the setup position of the 3D DISTO because I wasn't able to capture or lay out all the points from the initial setup because they were too close to the system. You see how precise I can lay out any point from another position.
I am now going to show the relocation procedure. The relocation procedure asks for a tolerance value. This tolerance value is a sanity check to avoid that secure points are mismatched or that any target marks have been put in the wrong position by someone else, or any other measurement error that might occur. We can set this down to 0.5 centimeter or to 10 centimeters. In the end, you are as accurate as your target. The tolerance only defines the threshold by when the system warns you that something might have been wrong. Now we measure 3 to 5 target marks again. Remember, there were 4 in this room. So we don't need to write down any point number, we just need to watch the pictures that the system takes automatically when you were shooting the secure points. So let's have a look at the first one. That was a target mark to the left. I go and pick this one. Yes, I want to measure second one. The one that's already measured has disappeared from the list, so I cannot do the mistake and measure the same point twice. So this one was straight ahead. Again, for location and relocation, it is important to target precisely. Now there are only 2 points left, and you see one difference if you measure the third point, that the system already drives to the place. But still you need to aim precisely, because otherwise it wouldn't be a control. Well, we are very close to this point already. It shows how accurately you can use the relocation. And we've got the last one, which was a natural target. It's actually the middle of a power plug. Here we go. So this is the shift of the position and the height of the 3D DISTO versus his first setup position. And here we go. You see that the target marks in use have turned from gray to black, to see that those target marks have been used for relocation.
I have finished the design layout, and now we have a look at this. So we start walking along the pathway. Till its end.
Finally, we have laid out all the points which are indicated by the red dots between the blue design points. We store choosing the home button, and after storage we go to the file manager and export the folder in the memory. The data are in the export folder, and here you see the subfolder design that contains all the export data. First there's a snapshot folder containing all the points, the secure points we've taken. It also contains DXF files, text file and CSV file with all the information. I have imported this DXF file in a simple DXF viewer. You see we have all the boundary lines from the surface, we have the control points here, and we have all the layout points as blue crosses. I can also turn on the point number layer, showing all the point numbers.
So you have seen how easy it was to make this layout using the 3D DISTO. We would have taken at least 13 setup positions laying out the 26 points of this place, which is 10 times 10 meter, if we would have taken a rotational or a line laser, while we did this with the 3D DISTO from 2 setup positions. We did this demonstration on a place that is 10 times 10 meter approximately, but you can expand a layout with the 3D DISTO of a range beyond 50 meters, choosing several setup positions and a location and relocation feature. You can also use a control unit like a receiver for rotational laser if you can't see the red dot. So it even would work in daylight conditions because you can use a crosshair and some sort of target such as a nail to really find the drilling position precisely. I hope this video has made you curious to have a look at the 3D DISTO in reality. Thank you very much for your attention.